Hey guys, welcome back. Today I'm gonna present a new sensor, a new digital sensor, that is BMG160. To have more knowledge, more insight for this sensor, let's have a look over the website, that is CONTROLEVERYTHING.com, and here we have to search for this sensor, that is BMG160. Now let's see what we got for this sensor. So this is a 16-bit triaxial gyroscope sensor, and the range, as you can see, from 125 to plus minus 2000 degrees per second. Now these are some of its more features, and you can also add to cart or you can purchase this sensor from this website. Now I'm gonna interface the sensor BMG160 with a Raspberry Pi and a Java code. For that I require the code. So let's have a look over the resource tab, and here is our Java code sample which we require. Now you can download the code from this very site as zip file like here, and you can also have the privilege to download the code from github.com. Their repository of ours is Control Everything Community. Now you can have two options from you where you can download the code. Now choice is yours. Next, we need to set up some connection devices, and along with the sensor, some hardware for which we require. So let's have a look over that and let's proceed further. Now this here is our sensor, that is 16-bit gyroscope sensor BMG160. Now this here is our Raspberry Pi. These are the GPIO pins of the Pi. Now to make a connection among the sensor and the Raspberry Pi and to connect other I2C devices and make this connection a lot easier, an I2C shield is required, which you can see on my screen. This here is available on our website CONTROLEVERYTHING.com. Now place this I2C shield over the GPIO pins of the Pi and make this connection. Now the binding factor to make a connection among the sensor and the I2C shield is this, a connecting cable. Make the connection among the sensor and the cable, and while making this connection, make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly we have to follow this rule for I2C shield. Now we need to power up our Raspberry Pi, and for that a micro USB cable comes into the picture. Gently insert it over the power jack. Now the last thing we need is to make a connection, internet connection with the Raspberry Pi for the working of the sensor. For that we have two ways. First of all, an Ethernet cable can be used. Gently push over the Ethernet jack. In case if we don't have the Ethernet cable, we can also use a nano USB wireless adapter, which is a lot easier and it might save your day for the internet connection. Now as we are done with the connections part, what we need is a code so that we can interface the sensor with that. So why not we have a look over that. Let's proceed. Now as we are done with the connections of the hardware, now what we require is a Java code so that we can interface the sensor with the Raspberry Pi. And for that, first of all, log into github.com, and here we have to search for the repository, official repository of CONTROLEVERYTHING.com, that is Control Everything Community. Now log in, and here we have to search for the sensor, that is BMG160, and here we go. So this is the Java code we are looking forward. Now let's have a look over the instructions to comply this code. First of all, we have to download and install the Pi4j library on the Raspberry Pi, and the steps are provided on this very link. Let's have a view over this link so for better clarifications, and you can see the commands, the information, the procedures had to be followed for this. Now let's have a look over the code now. We have the code, as you can see, it's a .java extension file. First of all, in the code, we have imported the required libraries, as you can notice, and created a public class named BMG160. Now, bus.getDevice will show the address of the sensor, that is 0x68. Now comes the writing part. We have selected the range register, that is 0x0f, and here we have FSR, full scale range configuration, that is plus minus 2000 dps, degrees per second, and the command goes here. Now in the next part of the writing section, we have selected bandwidth register, that is 0x10, and the bandwidth is 200 Hz, which we have written here. Now we are done with the writing section. As we can see, our sleep 500 ms for there. Now this is the reading section of 6 byte, where we have read 6 bytes of data constituting for X, Y and Z axis for gyroscope. Now we have the values. Now this is the conversion part of the data for gyroscope X, Y and Z axis, which is strictly according to the datasheet details of the BMG160 sensor. So as we are done with the calculations and the other part, we have to display the results on the screen, which comes here. Now X, Y and Z axis of rotation are being displayed, and the format is, as you can see, very raw. %D is the format. So we are done with very journal and very easy and simple code of Java for BMG160. Now let's see how it works. Now let's have a look over the practicality of this code. For that, first of all, we have to copy this entire Java code. Copy it and open up the terminal. Here create a new file, bmg160.java, as you can see on my screen, and here we go. Paste the entire code and save it. Now this is the command to compile the code, as you can notice, and it's being compiled. It's taking some time. Let's wait here, and we are done, good to go. And this is the command to run the code, the sensor. Now here are the values of X, Y and Z axis in rotation. Now when I try to rotate it, and we can see the X, Y and Z axis rotation being changed, and change continues as I continuously rotate. So this is how the Java code works for this particular sensor, that is BMG160 16-bit gyroscope sensor. So why not we look forward and see what are the benefits, applications and a lot more for this particular sensor. So just now we have seen the working of the sensor BMG160, the codes and explanation and a lot more for this sensor. The BMG160 is a 3-axis angular rate sensor that is made up of a surface, micro machine sensing element and an evaluation ASIC. The BMG160 is designed to meet requirements for consumer applications such as image stabilization, that is DSC and camera phone, gaming, image stabilization, gesture recognition and pointing devices. It is capable to measure angular rates in 3 perpendicular room dimensions, the X, Y and Z axis, and to provide the corresponding output signals. Now this sensor is available and can be purchased from this very site, that is CONTROLEVERYTHING.com, and you can have the code from the resource tab, and after that you can download it. Now you can have also the code from github.com, and the repository there is CONTROLEVERYTHINGCOMMUNITY. Now as I just want to make sure that in case if you want to understand any part of this video or any issue, you can check me or you put your queries on CONTROLEVERYTHING.com, and you can post any comments on the community page of this website. Now for articles and blog like this, you can check me on instructables.com, and to pursue more videos like this, you can subscribe our YouTube channel. I hope you are doing well and you like this video, and have a good one of yourself. Thanks a lot for the watching. Goodbye.